if you went to the thermostat and you were able to change the temperature by 0.001 degrees F, that would be probably 1,000 times the impact of all their hard work to get the styrofoam cups out of their cafeteria.
And that is the trap this episode gets into, mistaking highly visible sustainability activity for meaningful emissions reduction, and why measuring the full life cycle first can reveal that the real carbon hotspot lies somewhere entirely unexpected. Good morning, good afternoon, or good evening, wherever you are in the world. This is Climate Confident, Stories and Strategies that Cut Emissions, episode 287, and I'm your host, Tom Raftery. I'm away this week, so I'm sharing a conversation from my other podcast, Resilient Supply Chain, which I think is particularly relevant to anyone working in climate, sustainability, procurement, manufacturing, or product design. My guest is John Beath, CEO and Chief Technical Director of John Beath Environmental. We discuss why organizations so often misread their own carbon footprints, how raw materials and Scope 3 emissions can dwarf the changes happening inside a factory, and why life cycle assessment matters only when it changes real business decisions. One of John's examples involves a solar panel manufacturer that assumed silicon was its biggest carbon problem. The data revealed that it was actually the aluminium frame. Changing that one component cut the product footprint in half. My Resilient Supply Chain podcast publishes a new episode every Monday at 7 a.m. CET, with conversations focused on how businesses are responding to disruption, technology, sustainability, and risk. If you enjoyed this episode, search for Resilient Supply Chain in your podcast app of choice and hit follow. Normal Climate Confident programming resumes next Wednesday, August 5th. For now, here's my conversation with John. John, welcome to the podcast. Would you like to introduce yourself?
Yeah, thank you very much. I'm happy to be a part of your show here, and I look forward to wherever you might lead me. So I'm John Beath. I'm the CEO and Chief Technical Director for a small consultancy called John Beath Environmental. I know, really creative name. We are a combination of traditional air environmental compliance consulting, but also more relevant to this topic, probably sustainability. And in that space, we help a wide variety of clients work on life cycle assessment, carbon footprint, just general assessment of where they are in their journey and in trying to address environmental impacts, primarily carbon, but also other impacts as well.
Mm-hmm.
My background individually is, I tell a lot of people, I am a recovering process engineer. I started off in the traditional oil and gas space, working in a refinery, working to develop designs for relatively minor process changes, only to discover that not many of them ever got built. And because that's what entry-level engineers do, is they design things only to find out the project doesn't have any money. So I went along with that for a while and decided that wasn't going to be my calling. And I sort of tricked into moving into the environmental arena. They tried to convince me that environmental was going to be a good thing because it used to be where they sent people back in the day if they had made a mistake on the unit, and therefore we're going to send you to environmental. But things changed. The 80s, 90s, and 2000s were the upheaval and rebirth of environmental. And so I was through all of that sort of thing and eventually found my way in from the facility where I was working into consulting. And that's been quite a journey. I was in a large company for a long time and decided I wanted to branch out on my own. And so now for 11 years, JBE started to be just me, and I had no plan. And now we are a real consulting company, and we work with a lot of companies all over the spectrum from small to large, and we help them assess where they are and figure out where they want to be.
Nice. And do you think that background as a process engineer lets you see things that someone with a pure sustainability background, for example, that kind of background might miss?
Absolutely, times 10. We find a lot of our clients are people that came out of the business world or maybe have worked their way up through the company And they don't have that sense of putting things in perspective and making things practical and obvious and making good value judgments. And that's what we're in this business to do. And as we go through that, we learn things. And you go into a project with an idea as to what you're going to find. You go through the math, and every now and then you're surprised and things don't turn out the way you thought they would be. Then you have to decide, well, how important is that? And so part of what we try to do is put that in perspective. And I've actually written a book that does a really good job of that, I think. And it talks about equating results in things that people can really put into their minds. And so people use things like cars off the road to express
Mm.
how much a change in your carbon footprint might actually mean. And so actually in the book, there are 6 little case studies that we do where we literally develop the carbon footprint of an A to B kind of choice, and we put the answers in terms of cars off the road. We don't do that for every project that we do, but I thought that was a good perspective to kind of give someone who's not that familiar with the space a sense of how do you look at things objectively.
Yeah, it's quite an abstract idea, isn't it? Reducing carbon, because people don't see carbon, so it's very hard to visualize what the impact is.
Yeah, that's really very true, and I'm kinda used to things that you can't see because I started in the environmental world in a refinery, and there you're dealing with toxic emissions, and you're doing all these calculations about what the emission rates might be, but as you walk around the plant, you really don't see any of that. You
Mm.
don't smell it for the most part, but it is occurring. It's occurring at a very small rate, and so I was used to the concept that just because you can't see it doesn't mean it might not be of a concern. But fundamentally, carbon is different from the other environmental impacts because it doesn't have an acute localized effect. And so the way that you think about it is different because it's all about the dispersion across the entire atmosphere as opposed to the impact on receptors that might be close to your facility, which is kind
Mm.
of the world where I came from, is being concerned about that. And
Sure.
so all of a sudden, having a pollutant that's not a local concern was a different pair of glasses.
Yeah, and for companies who are looking at their carbon footprint and drowning in carbon data right now, does their data often tell them the whole story, or does it occasionally tell them the wrong story, or how does that work out for them?
You know, it's all about being in the right force. That's what we tell people continuously. And I'm going to share an example from the early days when I started working in sustainability. We were doing work for a large insurance company, and we went to their home office. They had just formed a green team, and they were going to try to pursue their impacts and try to make an impact on the environment in that way. The sponsor spent probably 30 minutes telling me how hard they had worked because they have a large number of employees at this site, and they
Mhm.
worked really, really hard to get the Styrofoam cups out of their cafeteria. And that sounded like something until I walked around and realized it's one of the largest office buildings in the United States. It's 5 buildings. They're connected underground by these massive tunnels, and the amount of square footage they have is massive. And so when you think about that and you think about if you went to the thermostat and you were able to change the temperature by 0.001 degrees F, that would be probably 1,000 times the impact of all their hard work to get the styrofoam cups out of their cafeteria. So, yeah, it's about getting people's perspective. And so, from a more practical and realistic standpoint, when you look at the life cycle of a product, say this water bottle right here, and we actually did the footprint for this water bottle. I actually went to the plant where they make this, which is actually in China. And anyway, you start with the raw materials, you start with the making and manufacturing of that raw material into the place where the manufacturer can use it. Then there's the manufacturing process, there's distribution, there's the use phase, and there's end of life. Each of these have impacts.
Yeah.
And so when we work with a client, a lot of them have their preconceived notion of where they think the problem is. And because what they see is the manufacturing facility, they are convinced that if they just can really tweak their own manufacturing process, they're going to have a tremendous result. Well, for this water bottle, as an example, it turned out that about 90% of their overall cradle to grave footprint was the raw materials. And so what the plant was doing really didn't have but maybe a 1 to 5% impact on the manufacturer of the process. And they were spending all their energy on manufacturing, and they weren't thinking about the raw material and what they could do to change their lot in life with respect to that.
How did they solve it? Or did they?
Well, you don't always solve problems. When you become aware of them, you can tailor your actions based on what you see. So, for example, with respect to this particular product, what they looked at was substituting different materials. They
Mm.
actually went to an aluminum material as a way of potentially going after this. And of course, the thing is, this bottle, while you might say, well, gee, it has a footprint. Why does this exist? Well, this is a multi-use bottle. And in fact, I don't know if you're familiar with this, but it has an inline filter in a straw. And it basically filters the water as you draw the water through the straw.
Mm.
So the fact that this has a footprint is important, but why is it here? It's here because it's replacing the single-use plastic bottle that you might have bought otherwise to get your drinking water, right?
Mm.
And so the idea is, obviously, and there have been a ton of studies on this sort of thing, which is better and to what extent. So one of the things they work really hard on is the thickness of the plastic, because obviously the more plastic you use, the more your footprint, but up to a trade point. And what is that trade point? Well, they break.
Yeah.
And one of the assumptions in this study, interestingly, was what's the rate of replacement of these bottles? Well, you might say,
Mm.
well, it's pretty sturdy. It probably could last a long time. And I've actually had mine for quite a while. But what you don't take into account is that people lose these things. They leave them in the gym all the time. And so it turns out that they've gathered some statistics and they figured out that for people that are actively using this product, might be as many as 10 water bottles per year, which I was shocked at. I don't remember the
Wow.
last time I bought a water bottle, but that was the number that they used. And is that number right or wrong? You can argue about that. But
Mm.
the point is this study of life cycle assessment has lots of variables in it. And the goal is to try to put all of those things into perspective.
Interesting. And at a high level, we see carbon footprints failing from time to time. Where do organizations most often misdraw the system boundary?
The system boundary is one of the things that gets disputed usually at the start of a project, hopefully, because that's not the kind of change you want to make after
Mm.
you've spent your time and energy and your money and your math, and then you discover, ooh, I left something important out. Now I got to go back and recalculate all my numbers. So it is something to keep in mind. And maybe an example of this might be when you start to think about recycling as part of the game and how that enters into the equation. So for the plastic material like this, the scenario was, at least in the US, the majority of the plastic ends up in a landfill. What does that landfill impact mean? Well, it can be significant depending on which way you tend to look at it. If you look at it in terms of the emissions from the weathering plastic, not much carbon is really going to get released from that in a landfill. However, the other side of it, which is what people don't think about, is the construction of the landfill itself. Because as I'm piling more and more of this material into the landfill, I'm now incurring a future impact for building more landfill space to take up for the landfill that you filled up with the water bottles. Now, it takes a lot of water bottles to fill a landfill, but
Mhm.
let's say we're talking about windmill blades instead. Now, all of a sudden, we have a huge problem on our hands. And in fact, we do right now, because these windmill blades, there's a heavy interest in trying to get those recycled. But it turns out that the energy to recycle them, because they're made of fiberglass, part of them is a fiberglass matrix. And to break down that fiberglass to a point where you can use that material for anything else is very energy intensive. And so when you consider the cradle to cradle cycle of a product, which is to say, once it gets to its quote end of life, does it really? Well, if you're going to recycle the materials, now we're starting a whole new life cycle, kind of the bottom end of the life cycle. And how we take that into account is another part of the life cycle business that can be confusing. And I'll give you an even better example of how the footprint can get confusing. Let's talk about the people who build solar arrays and wind farms. So
Mhm.
we did a carbon footprinting effort for one of the larger companies here in the US that does that. And their job is to build these alternative energy power plants. And so they're building them here and there all across the country. And there's energy associated with doing that construction. And that energy, what they refer to as scope 1 and scope 2, is the energy contribution of their company to that whole process. And so they're actually evaluated based on their construction activity. And so the more construction they do, the higher their footprint is. And so that might lead you to say, well, the best way to lower their footprint is to not build these power plants. Okay. But what you've left out of the equation is something that scientists call avoided carbon, which is because you built this power plant, hopefully you're displacing some fuel use that would otherwise have been a much higher number.
Mm.
So the more power plants you build and operate, the lower the overall footprint of the world becomes.
Yep.
But if you have tunnel vision and you focus just on a part of that, which is your company, and these alternative energy companies compare each other, and right now they compare each other based on their scope 1 and scope 2, which is literally a measure of how many power plants they built.
Yeah.
So yes, you can get more efficient at that. And there we look at some ways that you can do that. But overall, just saying to that company, hey, lower your footprint, that's one of those examples of something that's not a good idea.
Mm.
So you can see how this can be confusing if you don't have the right pair of glasses.
And so when you start a footprint from scratch, what's the first question you got to ask?
Well, obviously, where do your raw materials come from? And so this has to do with two key things: geographically, where they're located. And a lot of raw materials these days, it seems like, come from China, but not always. So that transportation process has an impact on the footprint, although because a lot of goods come and go from China, most of that is shipborne. And shipping turns out to be a really efficient carbon footprint element, meaning to say that the numbers that you get from shipping, because you have this massive ship, the numbers that you get are far better than if you're trucking it across the country.
Yeah.
So even though it's coming from a longer distance, you still make out better. The other part of the raw materials, though, which is much more important, is the energy that's required to extract them or maybe even to process them before they come to your manufacturing site for you to make the product that you need to make. That is a key thing, particularly if it's a lithium ion battery and you're getting lithium from a lithium mine. Okay. That's
Mhm.
going to have a huge impact. Everything has an impact that goes into your manufacturing process, obviously to varying degrees. So the first thing we ask people is, we need a list of all your raw materials. We need to know how much they weigh. We need to know where they came from. We need to know what transport method was used to get them from their point of origin to you. And if that supplier will actually provide you some data on their actual energy, can you share that? So that's what's referred to as primary data. That is
Mm.
to say, it's data from someone who's actually doing the manufacturing, not someone that's just using the product that someone else made. So if we can reach into that supply chain and get data for your exact process, then that's going to make your footprint better. If we can't, then we're forced to rely on published study data from environmental databases or from other manufacturers that have published their results. That's the start of the process: is where'd all this stuff that you need to make your product, where'd it come from? And then obviously you can imagine the next step would be, okay, let's focus in on your process and let's just make it a big black box. And let's say, okay, everything that crosses into the box, I want to know what that is, whether it's electricity or natural gas or water. And then on the outbound side, your wastes, your air emissions, I want to know what all those things are. So I can then try to put them in perspective and use some sort of established guidelines and suggested ways that one goes about adding all that up.
Right. And for the likes of reducing emissions, are things like bio-based or recycled inputs, are they recommended? Do they always drop your footprint? Or is it kind of not obvious that sometimes these can go the opposite direction?
It's absolutely not obvious. We have done quite a few studies where we have try to do just what I just described, which is crawl back into the supply chain, try to figure out what their manufacturing process was, try to determine how much energy that was. And if you just think about, recycling aluminum cans as an example, that process is very labor intensive. You're literally melting down that aluminum to make something else out of it. There is an energy burden for that. But compared to the energy burden to mine the aluminum to begin with, turns out that that's very, very positive to be able to do that. With bio-based materials, really, it depends. You'd be surprised the amount of energy that can be required to get a bio-based material ready to do its mission, whatever it might be. And sometimes we find that that's really good, that if there are waste materials that are involved, or they come into the process with a low footprint, then you can end up with a pretty viable alternative. But I would say from our experience in evaluating the bio-based raw materials that are used for packaging or a lot of other uses, only about half of them turn out to be better than their conventional alternative. And sometimes it can be because of physical properties too. It can be, say, I'm making a packaging material, it has to be a certain thickness, it has to be durable. Or, if I'm building a container for something and it leaks and literally the product spills out onto the grocery store floor, then we went too far with that, right? And so what you find sometimes is that the artificial materials, the plastics and various different kinds of more robust materials, you can get by with a lot thinner grade of that material than the bio-based product might need to be to perform that same use. So there's a trade-off. One of the things that we look at really closely is a term that I call follow the mass, which is basically that carbon more or less tracks mass, meaning that the more something weighs, likely, the more its footprint is going to be. Now, there are lots of exceptions to that, but if you want a really quick rule of thumb and you have a bunch of different things that weigh different amounts that you're putting into a process together, then weight is your friend. And I'll give you another concrete footprinting example. We do some work for companies that make eyeglasses, or at least I have in the past. And sometimes you find that people really want to protect those eyeglasses. So they've come up with these really rigid eyeglass cases that are really good at protecting the eyeglasses. Here's one right here. It's relatively thick. It's made of a hard material, right? But the thing about it is it weighs a lot. So if you consider the glasses that are in here from the case, this case probably weighs 10 times what the product weighs. So what would you expect if I'm doing the footprint of my product? This is going to be my culprit. And we literally have seen that in a number of cases, to the point where eyeglass manufacturers have been tempted to get away from the protective case like this. But wait, another trade-off. If I have a soft bag case for my glasses instead and they break, now the footprint of those glasses just went in half because they don't last as long.
Yeah.
So this process is all about practicality, trade-offs, and useful life is a really important part of the device's footprint. It's not just what you make of it. It's not just how much manufacturing energy, but really, really important is how long does it last? And a great example of that is solar panels. Solar panels are absolutely about how long they last. If in the early stages of making solar panels, they were made of relatively weak plastics, which when put in service in a really hot environment, say in Arizona, what was discovered was they didn't last nearly as long as they needed to. And it was almost a trade-off in terms of the footprint. If your solar panels were supposed to go 20, 30 years and instead they only go 8 years, then you just made a bad decision. So solar panel manufacturing companies responded to that, realized they had to get their game to a different level. And solar panels today are a lot more durable than they were in the early days, but it took a lot of R&D and it takes some more robust materials to get to that point. Again, another trade-off.
Interesting. So we're seeing that obviously measurement reshapes people's priorities. When companies finally do see their true hotspots, what kind of decisions do they change?
Well, In the world of life cycle assessment, there's one important thing that's left out, which is cost. When you read any life cycle document, you will never see a discussion of cost in there. And I'm not sure what the scientists were thinking when they decided they would do that, but if you're a practical business person, that layer has to be added on top. As you look at the options you have, you need to look at what's it going to cost. If I'm able to lower my footprint and my cost goes higher and my customers aren't going to pay that cost, then that's not where I want to be. Now, there's another interesting trade-off here, and that has to do with market claims. Most businesses that make a product are in a competitive situation. And it's competitive in terms of price, in terms of brand recognition, in terms of appearance, but also it's competitive in terms of the footprint. So what kind of claims can I make? That's governed by the kind of study I do and obviously the performance of the product itself in terms of its footprint. But if I can make a lower footprint material and my customers want that, and I can make the kinds of claims that my customers see, then I might gain market share from that. And so I recoup some of that investment in potentially higher raw materials cost by being able to capture more of the marketplace. So again, if you're a shrewd business person, you're going to take all this into account when you decide, what is my strategy? What things do I care about? What things am I going to act on? And which things am I not?
Hmm.
And so we are often put in the role of being a coach and having to enter into that dialogue and discussion with our client, try to get them clear on what it takes to make a supported claim, to make them clear on the impacts, the relative impacts of their footprints and the potential changes they could make and what those impacts would be. And then they have to add the cost layer that says, okay, well, yeah, but if we quit buying from this supplier who has this process for making the raw material, and instead we buy from this other supplier, well, they're going to charge us 20% more for that. Is that what we want? In the short answer, it's complicated and it depends. But what we're doing is bringing more of all of those variables to our customers, to our clients, and to the marketplace so that everyone is able to see clearly all those things, what matter and what doesn't. And to your point, which started this whole line of questioning, which was what happens when people leave things out? Well, clearly that's not where any of us really want to be. And the voice of experience is what helps you to see that. But this is a collaborative process. So we don't come to any situation with all the answers. And clearly our customers don't either. But it's going to take both of us working together, sharing our knowledge, and looking in places we didn't think we had to look in order to get that clear picture that clearly defines the whole system.
Okay. And when your customers do get the full picture, what surprised them most when they saw the full scope 1, 2, and 3 picture? I mean, I can imagine things like water, refrigeration, invisible utilities, those kind of things, because they're invisible, might not have crossed people's minds as a potential issue. Have you come across any things like that?
Well, yeah, and to take it sort of a slightly different direction, we've been involved recently with some clients who wanted to generate the carbon footprint around clinical trials for drugs.
Uh,
So this is a completely different system diagram and life cycle.
mm,
And the studies that we've done, although we've done some footprints of the drug manufacturing, what's interesting is the footprint of these trials and what has been found to be important. And we set out to prove what the client thought was probably the case, which is the manufacturer of the drug and all the things that happen, say, in a clinical facility are important, but what's a lot more important is the patient travel. It's amazing how big that number has come to be. And we published a paper at the American Center for Lifecycle Assessment last fall where we presented some of the results of the studying that we'd done and the amount of just the sheer footprint of clinical trial transportation in this country is a staggering amount. It's an amazing number of people that are involved in these trials, which typically involve travel. And
mm,
so what they were trying to do is determine to what extent could they regionalize better the travel aspect, because say you're in a cancer study and the cancer study is being conducted by a doctor who's in Houston. They're literally going to make people fly there from all over the country or drive there many times, probably 6, 7, 10 times. When you multiply that by the thousands of people, literally thousands of people that are in these studies, the footprint of all this is just, it's staggering.
Yeah.
It's way more than the footprint of the manufacturing of the drug, because again, it's all about follow the mass.
Mm.
What does the pill weigh? The pill weighs a really small amount. So I don't care how energy intensive that process is, it's never going to get on the same playing field with someone driving their car from Florida to Houston 7 times. And that's just one person in the study.
Yeah.
So what we learned about that was patient travel was a key thing. And we kind of knew it was, but we didn't realize it was as big as it really is until we started adding up all the numbers. And so this is making the move from getting the footprint for an individual product to making the footprint for everything that your company may do. So this is moving us from a carbon footprint product standpoint to a manufacturing footprint of an entire company, or maybe an entire industry sector or a type of practice. And we do those sorts of things as well, because sometimes you need that view of the whole industry to be able to figure out which things matter and which don't, as opposed to just getting the footprint for one specific water bottle.
Interesting. And on that, and on the assumptions, are there assumptions you had initially about carbon accounting early on that turned out to be wrong?
Well, yeah, actually, the very first life cycle assessment that I worked on was for a solar panel manufacturing company 20 years ago. And they came to us and said, hey, we make solar panels, but we've never done a life cycle assessment, and we need to prove that our solar panels are green. And I said, excuse me, could you say that again? Because I don't think I heard you the right way the first time. And so he restated it politely, and we said, okay. And 20 years ago, I really didn't know what a life cycle assessment was or how to go about one. And I was in a large company, and so I called our experts over in Europe, which they'd been at it far longer than we had, because that's just kind of where life cycle assessment study, that whole business, where it grew up. I talked to them and they said, yeah, we can help you do that. We'll show you how to do it. And so we got started. So we did the study, and they were really concerned about the silicone. And so I actually went to the facility and toured around there, and they showed me how they cut it. And there were 26 manufacturing steps that they went through before they had the completed solar panel. And this was 20 years ago. So they were maybe overly complicated then versus how they are now. We got through that whole process, and we added up all the raw materials, and they were certain that the silicone was going to be the problem, and that they had been working on trying to reduce the thickness of the silicone that they needed in the panel to be able to produce the same result, because they thought, well, this clearly, they were using my rule, kind of, right, follow the mass. However, what they were doing is putting these solar panels in these big aluminum frames. And it turned out that the footprint of aluminum is pretty high. And so when we did the math, what we found out is the silicone didn't really matter. It was all about the aluminum frames. And if they really wanted to get the footprint of their solar panels to a lower place, they needed to find a different material. So they did. They actually made a change, and they got rid of the aluminum frames, and they went to a really carefully engineered plastic frame. And they cut their footprint in half by doing that. So a real world example that actually happened. And so you learn some things. And when we started the study, we had no idea that that's how it would conclude. So you sometimes learn things that are shocking and will cause you to alter your direction. Not every company moves out on what they learn, but I guarantee you, with every one of these studies, you're going to probably learn something that you weren't expecting to learn. And that's what, for me, that's what makes it fun.
Okay. And have you come across any times when there was like a well-intended reduction strategy that actually made things worse?
I'm struggling to think of a case where, other than, I mentioned the people chasing their styrofoam cups. That was probably well-intentioned, but it wasn't negative. It just wasn't positive enough.
Right.
And I think that's more often the experience we have is that people don't typically make really bad moves, but they expend energy in areas that aren't as productive as other things they might do because they don't necessarily have either the right measurements or they're not choosing to look at them in an objective way. They have the preconceived notion of what they want to accomplish, and maybe it's because it's easiest for them. So
Sure.
that's another dimension of this whole thing that maybe I didn't mention, which is some things are easy, some things are hard. We had a manufacturing company that was using a raw material and they were looking at ways to make a change to the raw material. This is a Fortune 200 company. They had plants in 36 different countries
Hmm.
that were supplying this raw material that they were using at one of the key parts of their product. And it turned out that there were 4 or 5 different manufacturing styles or processes that could be used to make this material. And they pulled all their suppliers to find out which ones had which, and they found out that some of them had really good processes and some of them didn't. But the problem was with all these plants and with all this complexity, they had long-term agreements with a lot of these companies. So even though they wanted to be able to make a move, they really couldn't make a move very quickly. And so this was an example of what could have been a really great maneuver that took them a long time. It took them probably 5 years to move towards the processes that were lower in carbon footprint for making that raw material. It didn't happen instantaneously because people forgot about how hard is this gonna be. There are things you can change that are literally just an operational choice, a process, something you can do or not do, literally almost no activity on your company's part, maybe even no cost on your part. And those are the things that I love to find.
Mm.
Because typically when you're switching raw materials, that's probably going to be a cost. It's going to be hard. You can probably do it, but you're not going to be able to put it in the bank tomorrow. So what I really look for are process changes that can be made somewhere along the way that will make things better without a huge cost and without a huge barrier to entry.
And if you were starting today, what would you measure that most companies still ignore?
I think that waste is probably one of the things that companies don't spend as much time on, and they definitely don't spend much time on where it goes. And an example of that probably is the electronics industry in particular. They're one of the ones that face what has been a challenge for years. And if you think about computers in particular, people are told that after 3 or 4 years, a computer is pretty much useless and you need to replace it because the technology is getting better and better. And the same thing is true of cell phones. So you're creating this tremendous mountain of electronic waste. And there are raw materials in that waste that we're ultimately going to need. And we've known this for years.
Mhm.
What we haven't been able to do is come up with a way to cost effectively recover those things. And things like the lithium ion batteries, we're probably getting a little better about removing them from scrap, but a lot of the other electrical components that are going to be equally needed as we move through the next 10, 15, 20 years, we really haven't come to grips with that problem. And that's a key part of the footprint, which is not really being considered in the way that I would like for it to be, because we're not considering the avoided carbon if you are able to recover those materials versus if you're not. Because for every metal that I throw away and send to the landfill, I now have to make more metal by excavating that from the ground, as opposed to being able to grab what I already have that's in an inconvenient form. So I think the opportunity for the next age is to really look hard at recycling. Another key area besides electronics is fabrics. You're
Mhm.
starting to see people now take an honest look at what can be done with waste clothing to just not go to landfill and to try to take some of those precious fibers and reutilize those in a way that preempts the avoided carbon that otherwise happens to produce that raw material from scratch. So I think waste is the next environment. And probably my most important message from this is that we have to find a way, I think, to begin to get some of the most egregious precious metals back into recycling in a better way. And I'll use aluminum cans as an example. Aluminum cans are great compared to plastic. We've done study after study that show that aluminum cans are really good, but
Mhm.
only if we can get them recycled at a reasonable rate. And recycling is going really well in those places that have curbside, but I happen to live in a city where they don't. And in fact, across the southeastern part of the US, I would say probably only 10% of the cities really have functioning curbside recycling right now. So all those aluminum cans that those people are using are all going to landfill. Aluminum is not gonna be replaced.
Yeah.
It's not like biologically derived materials, it's gonna have to be mined. At some point, we'll be mining landfills for aluminum. I really believe that that's going to happen at some point because we're just not being frugal enough with that really important resource. So if there's one thing I'd love to see changed,
Mhm.
it's let's find a way to do that. And there is a way. There are some laws that have been started in 6 states right now that are going after the packaging components and are making the people that make a product that uses packaging, they're now going to have to pay a fee based on the amount of packaging they serve up into that economy. And
Mhm.
those fees are being used directly to subsidize more municipal recycling facilities, MRFs, so that we can expand the universe of places where recycling is occurring. Because right now, maybe a third of the medium-sized cities and almost none of the small cities have that kind of facility right now, and so we'll never capture those aluminum cans from those places unless we do.
Yeah. Yeah, there are producer responsibilities laws here in Europe which require exactly that kind of thing. And also
Yes.
there are recycling initiatives as well. There's one I know of in Ireland, for example. I'm initially from Ireland, although I live in Spain now. But there's a new recycling program rolled out in Ireland the last couple of years where they put recycling machines in retail outlets.
Mhm.
And so if I've bought a can or a plastic bottle and you have machines for both, I can bring them back to these recycling machines, put them into the machines, and I get paid for every one I put into the machine. And so that encourages people to recycle their plastic, their glass, and their tin, aluminium cans because they get paid for every one they put in there. And so the recycling rate in Ireland prior to this program had been, and there were a lot of curbside ones as well, but the recycling rate had hovered around 30 to 40%, and now it's in excess of 90%. So it's a hugely successful program.
Wow, and those are working at scale because,
Yeah.
there was a movement probably 10 years ago here in the US to try to implement those machines, and they never caught on primarily because the machines would malfunction way too
Ah,
easily. And so
okay.
someone would not follow the instructions, not do something completely right, and all of a sudden the machine's jammed and no one can use it. And so maybe it's just because we're not in the US, maybe we're not good at following instructions, whereas perhaps Europeans are better at that. I'm not
Or,
sure.
or, or maybe the machines have improved with time, or
I
maybe it's a
think that's probably
combination of
true.
things.
I I think that's a great solution. I love that idea,
Yeah.
and I'm wondering why that hasn't moved towards the US.
I'm sure it
Um,
will in time. It's a reasonably new program, as I say, in Ireland. They've rolled it out initially to 2,000 retail outlets throughout the country. Now, Ireland's a small country, so 2,000 covers a lot of the retail outlets.
yeah,
But since then, they're rolling it out to another 1,000, so it'll be to 3,000 retail outlets now. So it'll be hard to miss them, so and easier to find them. So it's been a very successful initiative, I gotta say.
and so are they then backhauling how are the machines mined then? Do they get backhauled by the companies that are operating the stores, or how does that work?
So there is a company responsible for rolling out the machines to all the stores, then managing the machines, taking away the bottles and the cans, etc. So there is a company responsible for all that, and then there's a whole payment infrastructure in place as well. Obviously, when you buy the bottle or the can or whatever it is, be it plastic or glass or aluminium, part of the price of the beverage or the food that
Right.
the package that's contained in the packaging is the deposit that you get back when you put the bottle or the can into the
Right.
machine at the end of the day. If I remember correctly, it's like 25 cents per bottle and 15 cents per can. Or that's at least what it started out at. I'm not sure if it's gone up or down since then, but that's roughly what it comes out at.
Back in the days of glass bottles that only a few of us can remember here in the US, that's how things used to work back when there was cash and money and all that. And then you had these big wood racks and the plastic bottles or the glass bottles would be put in that, and then the trucks would happen. But the reason I asked the question is that one of the things, again, you mentioned the comment about things that people aren't thinking about quite as clearly. It's the reverse supply chain that you're establishing here. So now, if I've got a truck that's going to the store and it's picking up these cans, now I have a new footprint for that trucking. So if instead those bottles could be backhauled by the same distributors that are already going to that store because they're coming to a truck full of goods, and now
Yep.
my truck is empty. So if I put material that's going back to a recycler into that truck and it goes back to another location, then hopefully I'm money in the bank. For you guys, as a small country, you're always going to be able to get that recycled material to some kind of a facility. But that's what we face in the US because we don't have that density of those facilities. So now we have to move that material over much larger distances.
Right.
And because we have to do that, that's going to create a really big burden if we can't utilize transportation that's already doing that.
Makes sense.
So that's the key to try. Again, this is all about the overall footprint. Remember what I said before? Our goal here, yes, we want to recycle precious resources, and that's one of the reasons for doing these things. But also, we can't kill the program by having it be too cost ineffective or too labor ineffective, and therefore have a footprint that's upside down. So that's why it's key to try to integrate that process into something that's already working on the back end. So it's great you're getting the customers to bring the stuff to the store. I love that idea. But it's when they get there, if I'm creating a new truckload, I'm not sure I'm as happy about that as if I can make the hauler who's bringing the milk and the bacon and the cereal to my store, if I can make him take that stuff back to the MRF facility, then it hasn't cost me anything because that truck still has to go back to some central point, right?
Makes sense, yeah. I'm not sure how they do the reverse logistics, to be honest, but that sounds like an interesting way of doing it, definitely. Cool. John, if people listening to the podcast only remember one thing from this conversation, what should it be?
I would say if you're interested in addressing your carbon, make sure you do a really good job of measuring where you are before you do anything. Because so many people jump in the water and they don't know how deep it is.
All right. And a left field question. If you could have any person or character, alive or dead, real or fictional, as a champion for measuring carbon, who would it be and why?
Oh, man. You should have coached me on that one ahead of time. Just for full disclosure, there was no coaching on any of the things that just happened, in case you're wondering if that was the case. But, I'm struggling here because I can't think of anyone who I would characterize as being someone who is a measurer, if you will. So who is, and maybe that's the point here, is that I can't think of that person. And what does that tell you? It tells you that this is missing.
Yeah.
I throw back your question as I can't think of one, but there's a reason. And that reason is I can't characterize anyone who I would specifically point out as someone who is the poster child of going out and getting people to understand clearly where they are. I mean, certainly there have been a lot of environmentalists who have inspired people to dive into the details. And I think there are lots of examples of that in terms of environmental toxic air pollutants. You can journey back into time and find lots of people that are in that space. But carbon is a new world. And there are a lot of people that talk about carbon. There are a lot of people that are engaged in sustainability, and there's a lot of discussion. It's surprising how few people actually get down and try to understand it clearly. And if, again, I can't point to a person, but I can say my book, LCA 103, teaches you how to do a carbon footprint. So if anybody who's listening to this podcast wants to know how they can do it themselves, this will tell you how anybody could do it themselves. And so maybe that's my substitute message for the one you tried to give me.
On the measurement point, I guess the only person that would come to my mind with respect to that would be someone like Peter Drucker. Just given he famously said, if you don't measure it, you can't manage it.
Well, that's true. And when you think about it from the standpoint of people who are teaching management in general, yeah, you can find, a lot of people that will talk about the measurement, the whole management cycle, plan, do, check, act. That's the ISO version of it. But there's also plenty of, Harvard and Princeton, all these other people who have their own management things. And I don't have an MBA, so I can't speak too deeply to any of that stuff. But yeah, I think it's a management concept that's trying to be repurposed into the scientific world.
Yeah.
Because we are talking about some relatively complicated science to try to translate these principles into meaningful results and then figure out what to do about them.
John, we're coming towards the end of the podcast now. Is there any question that I didn't ask that you wish I had, or any aspect of this we haven't touched on that you think it's important for people to be aware of?
Let's talk a little bit about green claims, because I think that there are a lot of people in the marketplace that are in a rush to do some numerical calculations and rush out and draw some conclusions about how great their product or service might be. A lot of those people are not getting all the steps right. So one of the things that we are asked to do is support clients who are paying us money to do studies for them. And as part of that, we find ourselves as being really the referee that has to say to these clients, well, listen, there's some rules. The ISO standard community has put together some guidance that says if you are going to publish some results and make some claims, then it needs to be third-party reviewed. First, you need to produce a report that follows the ISO guidelines for the things it's supposed to contain, and then you're supposed to have a third-party reviewer look over the information following the ISO standards, spot check your math, make sure you're covering all the bases you're supposed to. Did you draw that system boundary in the way that you're supposed to? And only at the end of that time are you licensed, if you will, to make a claim about the attributes of your product with respect to carbon or anything else you might have studied. Because carbon is one of many environmental impacts that get studied in a life cycle assessment. Other things like resource depletion and the quality of your water supply and toxicity to plants and animals and to people, all of those things could potentially be studied. And claims could be made about all of those things as well. But it is important to follow the process. And there's a lot of companies out there that aren't following the process. So what we say to interested stakeholders is kind of buyer beware. Look for life cycle assessment. Look for third-party reviewed when you are viewing some claims that people are making out on the web or in their advertising.
Good advice. Yeah, great. John, if people would like to know more about yourself or any of the things we discussed on the podcast, where would you have me direct them?
Probably to my website would be the first place to go. It's beath.us, and that's my last name. And there you will find a lot of good information. And in particular, you'll find a place where you can download all three of my books for free.
Great.
So you just have to fill out a form. And LCA 103 is the one that's about carbon footprinting. That's the one that's probably most germane to this particular discussion. And I think it's only 20 pages long. It's only 20 pages and you'll become an expert on carbon footprinting. Who else does that?
Fantastic. Great. John, that's been fascinating. Thanks a million for coming on the podcast today.
All right. Well, thank you for having me. I enjoyed it. And good luck to you in your future casts in the future.